A lot of times you'll hear things about data being normally distributed, or you probably are more familiar with things like this is a bell-shaped curve. I'm going to draw a bell-shaped curve. They can come in, but they're going to look like a bell. But they can be a tall and skinny bell, or it could be a short and wide bell, or anything in between. But it'll still have that bell shape. So I'll try to draw a couple of them. Pretend they're perfect. So that would be a tall and skinny bell-shaped curve. It could be that it's wider. The data is more spread out and shorter. But both of those would classify as bell-shaped curve, a normal distribution. Now, I do not draw it correctly. Well, I'm drawing it freehand, so it's not going to be a perfect bell. But I also do not draw it close enough to that horizontal line. On the edges, I call it the fringe. It really should be almost touching the horizontal line. But in reality, it never touches. I leave a little extra space because I want to have a little space to write some notes in there. I'm Googling normal distributions right now. Let's see what kind of pictures I've gotten. Here, I'll put it on the computer. So, let's see if this will enlarge. You can see there's examples here. There's several examples of normal distributions, bell-shaped curves. And if you look at the pictures, that's a pretty good one right there. That's actually what we're going to talk about today. I just happened to hit upon it by luck. So here's a bell-shaped curve, and if you look on the fringes, it looks like the curve is touching the horizontal line, but in reality, it is not. And so again, I will draw them to where there's really more space there than would be in the real world. What we're looking at in 12.4 is called the 68, 95, 99.7 rule. All right, in this section, we study the 68, 95, 99.7. These are percentages rule. Maybe I should have written percent after each one. And what this rule tells us is that in a normal distribution, all the data, or not all the data, 68% of the data is within one standard deviation of the mean. 95% of the data is within two standard deviations of the mean. And 99.7% of the data is within three standard deviations of the mean. Let me write that out. This rule tells us that 68% of the data in a normal distribution, let me put that up here. This rule tells us that in a normal distribution, I should mention that. that 68% of the data is within one standard deviation of the mean. It tells us that 95% of the data is within two standard deviations of the mean. And it tells us that 99.7% of the data is within three standard deviations of the mean. 99.7% of the data is within three standard deviations of the mean. Sometimes students will look at that and they'll ask, how did you get those numbers? And my answer to that is somewhat of a cop-out answer. It's mathematicians and statisticians have studied this for years and have shown that these are the numbers. How did they get them? It's way beyond the scope of what we're doing in this class. So just know that those are the numbers, and that's what we're working with.